Thanks, everybody. Thanks for having me here. I'm really happy to be here. And today we're going to talk a little bit about how to deliver web pages with both fast and beautiful images. Bruce gave me a great introduction, but just real quick about me. I do a lot of developer relations and help people speed up their websites and their native apps. And I lead workshops on performance, on images, video, how to improve video on your web pages, AR. If you're interested in app development, I wrote a book on how to speed up Android apps, and that's the PDF, so feel free to grab it. I'll tweet the slides out later. And then if you ever have any questions or want to talk about performance or images or video or any of that, I'm the only Doug Sillars on the internet, so I'm really easy to find. So I've been traveling all around Europe, and one thing when I get to talk about images, I get to show really cool pictures. And so how many of you, when you see this picture of a walkway nailed to the side of an Alp, get a little nervous thinking about walking across said walkway? Anyone? Yeah, okay. That's a pretty good number of hands. So this is in Grindelwald, Switzerland. Walked across this with my family, and my 6-year-old daughter decided to jump the whole way. So it added this nice rattling sound as you walked across it. But about 3 years ago, Ericsson did a study, and they put sensors on people's heads to measure stress responses to different things. And they found that when you thought about queuing up for a line, it sort of raised your stress level a little bit. They found that thinking about walking across a cliff stressed people out a lot as well. But really interestingly, if you have a slow mobile website, that's actually more stressful than standing on the edge of a cliff. So if we build web pages that are slow, your customers are frustrated, they're stressed out, and when people are stressed out, they tend to not repeat visit to your website, they tend to buy fewer things, right? And there's a lot of data about this. Google found that 53% of people abandon after 3 seconds, people get more frustrated and less engaged. Amazon and Walmart 20 years ago found that people spend less money, and it's measurable at 100 milliseconds. My favorite stat is 4% of mobile users admit to throwing their phones when there's a slow mobile experience. And so we start thinking about what can we do to speed up the web, and this is from the HTTP archive. So this is looking at a random 10,000 websites, and you can see as the web pages get bigger, and we're at 50% images in kilobytes. And as you get to bigger and bigger web pages, it gets even higher, almost up to 75% of the page is images. So if we can speed up the delivery of the images, we're going to speed up the web page. So let's figure out what we can do to speed up the images that show up on the web. Lighthouse is a great tool that audits how pages load on mobile. And inside Lighthouse, there's 4 image optimizations. There's quality, there's format, there's sizing, and lazy loading. When I ran this, the scores are between 0 and 100. They've just changed the scores in the last few months to 0 to 1, but it's divided by 100. We can work that one out, I think. So what's really cool about this is that Lighthouse is built into web page test. When you use web page test to test your website, which you should all do, you can test it around the world. You can see how your page loads. You can test different devices. Web page test can run Lighthouse tests, and the HTTP archive is built on top of all of this. And the HTTP archive trawls now 4 million websites every month, puts all of that information in a database so you can figure out how the web is built today. When I ran this study, it was 500,000 websites, but you get the idea. We have a lot of data here to see how images are being used on the web. So let's see what we found. The first thing we're going to look at is image quality. And what Lighthouse recommends is they recommend that you save all of your images at 85% quality. Now, we all know when you lower the quality of a video or quality of an image, we're lowering the number of pixels. It could not look as good. Google found in general 85% is good enough. It's really, really easy to do that. You can use Image Magic. You just set it to quality 85, and out comes the quality 85 image. You can use a cloud-based tool like Cloudinary, where you upload the full-size image, and you just put the term Q85 in the middle, it spits out a Q85 image. And so if you take this image that I took of Riga, it's 3.6 megabytes, I save it at 85%, and it's half the size. It's now 1.87 megabytes, just by changing the quality. And if you look, you probably can't tell the difference. It still looks like the same image. If we look at what's in the HTTP archive from those 500,000 websites, we find that 43% of the web is getting 100%. That's great, that's awesome, but we also see that a full third of the web is completely failing and getting a 0. And so that's really bad. And inside the Lighthouse score, if you get a low score, it can tell you how much you would save if you actually made this fix. And so we've got 33% of the web that's failing. I can see what the 50th percentile app website would be. It would be 2.8 seconds faster and use 420K less data, right? So if we can make a web page on mobile load 2.8 seconds faster, that's pretty huge. But couldn't we go even better than 85%? 85% is like Google statistically finding like that's a good place to be. Can we do even better than that? You can look at 50% and you can see a little bit of kerning in the sky. Sometimes you can't. At 20%, you totally can. It looks horrible, right? We wouldn't put that up on the web. So we know that we're good at 85%. We know we're bad at 20%. But where's the sweet spot in the middle? There are tools that'll do this for us. Booter Augly, structural similarity. There are a bunch of tools out there that can find the optimal place where the quality is lowered to where the human eye can't tell a difference. So if you lower it to a quality where the human eye can't tell a difference, you've made it the optimal size and quality for everyone. You can use CJPEG DSSIM. You can use the QAuto with Cloudinary. And when I do that, I get an image that looks like this. And it is imperceptible from the 1.87 megabyte version I showed a little bit ago, except for it's 400K lighter. It's going to get delivered to the phone or to your customers a lot faster. And you can see, there's the graph, it's 400K less. In addition to that, we can run all these images through web page tests and see what happens. And you can see the full-size image is 21 seconds. The structural similarity is 9.5 seconds, right? Even from 85%, we sped up a couple seconds. All right. The next thing we want to look at is the format of the images. And obviously, there are a lot of different image formats out there. Here are the average sizes based on the HTTP archive. Most of the images out there are JPEGs. And the biggest images out there are JPEGs. But let's talk about some of the other formats that are out there. Let's first talk SVGs, scalable vector graphics. These are really awesome for icons, right? They're drawn as shapes, they're infinitely scalable, and it's XML, so you can put it right into your HTML document, you can inline them, and you can stretch them infinitely. If you see pixelization here, that's because I'm using PowerPoint, and PowerPoint doesn't support SVGs, so I had to take screenshots of the SVGs. Anyway, if you use them, they're infinitely scalable. But there's some interesting things you can do and some funny things that I found on the internet that make this, that you can screw up with SVG. So I found a web page that has this sort of bullseye logo on it. And I noticed some funny things when I was looking at the waterfall and web page test. And I was like, well, let's check out this SVG. And the first thing you can see is you see the XML. It's a text file, right? So you can open it up. You can see some circles. Like, that all makes sense. And then you see line 30. It says Adobe Illustrator. And then, like, you're like, well, what the heck is all of that? Well, it turned out the reason my interest was piqued by this file is that it's 946K. And for an SVG made of vectors, that's just like, it's way too large. So what I did is I grabbed right there at line 30, dragged to the bottom, hit delete, resaved it, and it went down to 1 kilobyte. Right? Test your stuff before you push it into production? I don't know. Of course, you can gzip it. You can use Brotli. You can get it down to 0.5 kilobyte. You can put this into your text. It's a lot smaller. So that's cool. That's an easy fix. Then I scrolled further down the page. Orange. Same exact problem, 946 kilobytes. They've got 1.8 megabytes of SVGs on this web page, right? That's a problem. They could do the same thing I just talked about by resizing it, or you could just style the red one to turn it orange with 2 lines of CSS, and the red one turns orange, and you've got 2 lines of CSS, 500 bytes of SVG, and you're good to go. Or you can go the 1.8 megabyte approach. Obviously, we know which one is going to load a lot faster for our customers. Let's talk PNGs really, really quickly. Another thing I've found looking through a lot of web pages and looking at waterfalls and Chrome dev tools is screenshot _ 2018-12 right? So there are designers out there that are taking their images, they're making them look really, really great in Photoshop, and then just taking a screenshot. and putting it to production. Like tens of thousands of these are in the HTTP archive. It's pretty crazy. I found one that was 14 megabytes, and I just want to know how big that person's screen is, right? Like they had to scroll over and over and over again. But the thing about screenshots is they're not optimized, right? They're not optimized for the web in any means. And so I took 3,000 of them, and I wanted to see how much smaller I could get them. 86% of them were at least 50% smaller. 35% were 90% smaller just by turning them into JPEGs, right? The screenshot tool on your Mac isn't designed to put stuff live onto the internet. Much to the chagrin of a whole lot of web developers or people who are out there doing it today. So we shouldn't do that. But one thing we can do is we can look at other formats, like the WebP format. And if I had been giving this talk a year ago, people would say, well, that's just Chrome, that's just Android. It's improved a lot. We've got it in Edge, we've got it in Firefox. It's under, they're looking at it in Safari, right? So WebP is supported in a lot of the major modern browsers today. And if you turn that image that I had of Riga and you turn it into a WebP, it goes from 1.4 megabytes down to under 1 megabyte. So another 400K saved just by changing the format. So it's something you should look at doing. And Bruce asked me if I had a picture element in my slides. Thank you, Bruce. If you want to serve WebPs, you can use the picture element. If WebP is supported by the browser, it will show the WebP. If it isn't supported, it'll fall back to the JPEG, and then you should always have an alt tag because accessibility. And you can see the structural similarity JPEG takes 9.5 seconds. The WebP takes 7. We shaved off another 2.5 seconds to download. So that's really, really cool. According to Lighthouse and the HTTP archive, 2/3 of the internet is failing at this. It's just all JPEGs, as you might expect. If the median web page of those that failed switched over, it would save 4.1 seconds on load time and 600 kilobytes, right? It's a pretty big win for a fairly simple fix if you're interested in doing that. The next thing, this one is sort of common sense to a lot of developers out there, but is image resizing. You don't serve the same size image to a mobile phone that you serve to a desktop, but we'll walk through it. So a picture of a cathedral, it's 13 million pixels. It was originally 1.6 megabytes. I do all the stuff we just talked about, structural similarity to lower the quality, WebP, and it's half the size at 800K. But it's still 13 megapixels. And so you download that on a tiny little phone, and you download 13 million megapixels, 500,000 are shown on the screen. That means the phone has to throw away 12.5 million pixels. So it's sort of like a double taxation. You have to download the whole file and then throw away 95, 97% of the file before it can show up on the screen. The closest analogy I can come to that in real life is when you order something online and you get this big giant box on your front porch and you have to go through like miles of bubble wrap before you find out that your kids ordered like a pencil, right? And we always laugh when you get a package like that, but we're doing that every day with our images online, so we should be really careful. Now, to throw on top of that, throwing away that 95% of the image takes time. So let's see what that looks like. Here's an image that was 16 megapixels. It ended up being 1 million pixels on the screen. I downloaded it on the desktop. The image decode took 78 milliseconds. A Motorola G4, which was high-end a few years ago, is sort of a mid-range Android device now, takes 200 milliseconds. The Alcatel One X you can buy today. It's an Android Go device, and I was in a store a couple weeks ago. They were about, I was in the UK. They were about 45 pounds each. They're really, really cheap phones, so they're selling a lot of them because they're the ones when you go into the phone store, they're the ones that aren't plugged in because they don't want anyone actually seeing what the screen looks like. But it took 820 milliseconds for the image decode. So it downloaded, and then you had to wait a whole nother second, and probably the back of the phone gets all warm because you're using the CPU, you're draining the battery, right? So we should really resize the images. Of course, this is difficult because there are a lot of different devices out there, all with different size screens. This is one day at Akamai. The size of the box is how many devices The color of the box is how fast the CPU is. So green is fast, those are all Samsung Galaxy devices, but there are a lot of devices out there towards the event horizon in the corner that are really, really slow. So we should generate a bunch of different size images. In this example, I generated them 25 kilobytes different in size. And when I download it on my pretend mobile device here, I only waste 100,000 pixels instead of 12.5 million. I use the responsive breakpoint generator. You can get it from GitHub, or there's a web interface. I used the web interface because it was easy. It just downloads a zip of all the images. When I test it, because now I've thrown away a whole lot of pixels, it goes from 7 seconds on the download to 2, right? 1 megabyte down to 121K. Now we're talking, when we look to see what this looks like in the HTTP archive, 60% of the web is doing this perfectly right, but 22% is completely failing. Those sites that are failing would be 2.7 seconds faster, 400K less data. Really important. We should look at sizing the images properly for our devices. Maybe 25K different isn't right. Maybe you only need 5 images, but you can figure out what that is from your analytics. The last optimization isn't a specific image fix. It's something to fix for your whole page. It's lazy loading. And probably most of you are familiar with what lazy loading is, but the idea is only download the images that are showing up on the screen initially. By removing those 4 images that are below the fold, the page is going to load faster. And then you can use JavaScript to have those load in later. When we look at the HTTP archive, most of the web isn't doing this. 60% fails. The web pages would be 3.5 seconds faster on mobile, 530K less data just by not loading the images that are below the fold. So you've seen what this looks like probably. Medium does it, Facebook does it. Google image search does this on the phone. So if I search for cats in costume, you sort of get these colored SVGs that correspond to the color that's coming in. So the cat dressed up like an alligator is in green. The cat dressed up as a bunny is in pink. And these are SVGs, so they're super small. They're preview images. And then when the full-size image comes in, they appear. If you want to go fancy, you can use SVGs with a little bit more texture than just one color. So this is called Squib, and you can see there's a little more texture than just green. There's a little bit of the waterfall feel to it. And again, it's like 900 bytes. That loads before the image comes in. So what can we do? Let's look at what lazy loading looks like. I built a really, really slow web page. It's got like 15 megabytes of images. These are the different viewports on the desktop. I just zoomed it way out. And when I load this up in Chrome today, you can see the text is constantly reflowing. The images are loading sort of in random order, like the cow here loads before the images above the fold load, right? If you're looking at this web page, you're waiting for all the images above that red line to load. You're not looking for the cow or the house or any of these other images to load first, and they shouldn't load first. However, they're behind a flag today, and I think they're promising it to be released pretty soon. Chrome is going to have this lazy loading set up by default. And so this is what it looks like. And what Chrome does is it finds all the images. It makes a request for the first 2 KB of every image. And in that first 2 kilobytes, it gets the dimensions, and it can figure out the location of all the images. So it can lay out the whole page. You can see the text stops reflowing after number 3. And it's got the whole page. I've got preview SVGs in place. But you can also see now that it knows where the images are on the page, it can start loading the pages from top to bottom. And loading from top to bottom makes a lot more sense because that's the way we all scroll down web pages. So it's really cool that this is coming soon. For everyone else, you should use one of the for everyone other browsers, you should use some of the lazy loading libraries that are actually working with the Chrome experiments as well. The next big thing when it comes to images that I see being misused on the internet all the time, it's animated GIFs. We all love animated GIFs. And when I lived in Seattle, I had goats. And this is Nora. And I took a video of Nora using my phone, and it's 1.4 megabytes. And I turned it into a GIF, right? Because we need more goats on the internet. However, when you turn it into a GIF, it becomes larger. It's 270% larger. And you start to think, well, why is it larger? And we can rewind back to 1990, and we can go to the spec for the GIF format. And in the spec for the GIF format, it says the GIF format is not intended as a platform for animation, even though it can be used that way in a limited way. So the people who invented the GIF said we shouldn't be doing animated GIFs. That ship has sort of sailed. So what's happening is, because this is from the 1990s, is it's literally, if you have 15 frames per second, it's literally 15 GIFs being flipped through every second, which makes them larger. So what should we do? We should serve them as MP4s. And so I took the GIF I had, I made it 256 colors. I stripped out the audio track because, one, the sounds of goat eating, rather unattractive. Two, GIFs are silent anyway. And it's only 250K. Of course, that leads to people to say, but what about social media? Like Twitter says these are all GIFs. For those in the back, I enlarged it, right? They're lying. If you actually go into DevTools, it's an MP4, right? They call it a GIF. It's GIF the medium, not GIF the format. And you can see it's 400K. And the reason they're doing that, obviously, is 400K gets downloaded faster. It's less, data transmitted. It saves a lot of, it makes the page faster. So you should always just make it a video tag. You have to say loop autoplay muted, because on mobile, videos won't play unless they're muted, even if they're already silent. And that's because I'm pretty sure that Chrome and Safari engineers sit in meetings too, right? And we don't want the video to be loud, because then we're busted. If you're interested, here's my second picture tag. In Safari, you can actually put videos in the picture tag, and they'll play. So in this case, on Safari, it'll loop through the MP4, fall back to the WebP for Chrome, and then everybody else gets the GIF. And why that's important is the video file on a 3G connection loads in 4.5 seconds, whereas the GIF can take up to 22 seconds. So huge savings, huge performance improvement when it comes to doing video over GIFs. Now, those are sort of the basics of what we can do, but there's even more that we can look at. One thing that's really cool is we can look to see what our customers are saying. And so how do you do that? In mobile Chrome, there's a data saver setting. And if you turn that on, it adds a header to all of your requests. Save data is equal to on. And so if your server is getting people to say, if people are telling you, hey, I want to use less data, you can serve them smaller images, fewer images, maybe take out the video. And you may be thinking, how many people are doing that? Here's some data from October where one web page has 5% of their customers saying, I'd really like a lot less data, please. Please don't serve me all of that stuff. Well, if 5% of your users are saying, don't do that, maybe we should look to see if that's worthwhile doing. Tools like Cloudinary do this automatically, so going from the structural similarity automatic, it will downgrade it to a subset of that, and it'll actually save like 45 kilobytes on this specific image. It automatically does that. So you could build this sort of thing into your tool chain, maybe hide the videos, do other things. If someone's saying, give me less content, maybe lower quality images or something like that. Another cool thing you can do is there's a network info API. So you can actually ask, how fast is the network connection? And if the network connection is slow, right, serve them less stuff. Because if things don't work, people get frustrated. As part of my trip, I got to spend a month in rural Cork. And my Airbnb said, high-speed Wi-Fi. But they didn't say that it was connected to a 3G router that was on edge. And it was really slow. I have a screenshot of a ping to Google that took 400 seconds. Seconds, not milliseconds, seconds. That's like minutes. That's a really long time. But when I used my phone on that Wi-Fi, I never saw a video. I never saw any GIFs playing when I was on my social media, because all of those companies, the Facebooks and the Twitters of the world, knew my connection was too slow, and they just hid them. And then when I went into town or someplace that had a fast connection, they would reappear. So you can hide those things if you know they're not going to play. So that's another thing we can look at. So in conclusion, I've got some images stuff here, and we can talk about videos really quickly. But we should look at optimizing the quality, format, resize your images. We should lazy load if possible. Turn all your animated GIFs into movie files. Don't base 64 encode the images. And monitor your customers' headers. Because if they're saying, I want less stuff or my network connection can't handle it, don't deliver it to them. When it comes to videos, it's sort of the same thing. Like, I see so many web pages that hide the video on mobile, but still download the entire video on mobile, and that's just horrible. Streaming is the way to go. That's a whole other talk. But video can be really, really expensive because they're really, really big files. So in conclusion, I used web page tests and HTTP archive to see what the web is doing today. And then I used image magic, structural similarity, lazy loading, responsive breakpoints to build images that are faster for the web. Those are where you can find all of them. I used Cloudinary for a bunch of the examples. In conclusion, images really can be beautiful and fast. So you should look to do that. And if you're really interested in learning more, there's tools like Cloudinary. They have a media developer expert program. You can reach out to them. But really, we really want to speed up. If you want to speed up the web, an easy way to do that is to make your images faster. And so with that, thank you very much for your attention. I appreciate it.